All right, so here we have the kidney. We have the outer layer, which is called the capsule, brown region here. Just inside the capsule, you have the region called the cortex. And deep to the cortex, you have the medulla. Capsule, cortex, medulla. Now structures. You have the renal pyramids here. All of these are pyramids. They contain the functional unit of the kidney, which is called a nephron. You can see one here. In between the pyramids are the renal columns, which allows the blood vessels to make their way up from the hilum all the way towards the capsule. So looking at the renal artery, which splits to become the segmental artery, then the interlobar, then the arcuate, and then the interlobular. Then we have the renal papilia at the bottom of the pyramid, which is where formed urine is dripping into the minor calyx. These little cups are the minor calyx. The minor calyx is merged to form the major calyx, and the major calyx is merged to form the renal pelvis. So if I'm asking you to identify just this region here, this is the renal pelvis. If I include the pelvis, the renal artery, and the renal vein, this would be the hilum. And of course, this is the urethra that's going to travel down and enter into the bladder posteriorly. This is just an isolated section of the pyramid and the cortex. And you can see there's a number of glomerulus. There's 1 million of these in each kidney, all up here in the cortex, and the associated blood vessels. You can see the proximal convoluted tubule, the descending limb, the loop of Henle, the ascending limb, the distal convoluted tubule, the collecting ducts, the papillary ducts, which drain into the minor calyx, major calyx, renal pelvis. Now looking at an isolated glomerulus here, you can see the afferent arteriole and the efferent arteriole. Now look at the diameter of the two. The afferent is larger in diameter than the efferent, and that's going to drive the pressure gradient up inside the glomerulus. This vascular network here, called the vascular tuft, is a number of many capillaries that allow for filtration. Filtrate enters into the capsular space here, which is between the visceral layer and the parietal layer, and that forces filtrate into the proximal convoluted tubule. All the way at the end of the tubule system is the distal convoluted tubule here, where you can see the macula densa cells inside the distal convoluted tubule and the juxtaglomerular cells, which are inside the afferent arteriole. Notice that the distal convoluted tubule rises up between the afferent and efferent arteriole. So now I want to switch over to this model here, and I want to start with the blood vessels. These blood vessels here are the arcuate artery, arcuate vein, and then you have the interlobular artery and vein. The interlobular artery gives rise to the afferent arteriole, enters into the glomerulus, and exits as the efferent arteriole. In this case, the efferent arteriole is giving rise to the peritubular capillaries here, but in this case, the efferent arteriole is giving rise to the vasa recta. The vasa recta goes straight up and down deep to the medulla and up, where the peritubular capillaries surround the tubules, where you can exchange, recover, filtrate, and send it right back into the blood supply. So let's say, hypothetically, glucose in the afferent arteriole, filtered by the glomerulus, enters into the proximal convoluted tubule, where it's recovered into the interstitial space, back into the peritubular capillaries. This is now part of the plasma again. From the proximal convoluted tubule that I went through the descending limb, you have the descending limb, you have the thin limb, you have the loop of Henle, the ascending limb, the distal convoluted tubule, the collecting ducts, the papillary ducts, which drain into the minor calyx, major calyx, renal pelvis. Now this is a cortical nephron, and has a shallow loop of Henle, where you have a juxtamedullary nephron here, which is much, much deeper. And I'll explain in lecture how the concentration gradient in the cortex drives the water out of the thin limbs, making it more easily recovered by the vascular side. But even though this is a cortical juxtamedullary nephron, it has the same components. Proximal convoluted tubule is attached to Bowman's capsule. Most of the recovery takes place in the proximal convoluted tubule. Then you have the thin descending, the loop of Henle, the thin ascending, and right here it becomes thick ascending, distal convoluted tubule, collecting duct, papillary duct to the minor calyx. I'll do those other two tomorrow. They're